Welcome to Spaceverse, your portal to cosmic adventures. A groundbreaking revelation has emerged from a gathering of the world's leading scientists. Time does not flow uniformly across the universe. Instead, it unfolds differently depending on location, challenging our deepest assumptions about reality itself. This revolutionary perspective is now being reinforced by the latest images from the James Webb Space Telescope, which continue to reshape our understanding of the cosmos. The telescope's breathtaking discoveries, coupled with an ongoing cosmological crisis, have cast doubt on long-standing theories about the origins of our universe. For nearly a century, the dominant belief has been that the universe began as a singular point in an explosive event known as the Big Bang, expanding continuously for the past 13.8 billion years. However, Webb's astonishing images suggest something even more perplexing: the presence of galaxies that appear to be older than the Big Bang itself. These findings don't just question our understanding of galaxy formation and evolution. They shake the very foundations of the Big Bang theory and our entire concept of cosmic expansion. Could we be on the brink of a paradigm shift in physics and cosmology? As we stand at the edge of a new scientific revolution, one thing is certain: the universe is far more mysterious than we ever imagined. What's even more surprising is that hints of these inconsistencies have existed for years, yet many researchers overlook them. Now the evidence is undeniable. These unsettling results have prompted an urgent meeting of top cosmologists, including Nobel laureates and leading experts, to re-examine fundamental assumptions about the universe. Key topics of discussion included the influence of dark energy and the nature of cosmic expansion. One particularly intriguing idea that emerged is timescape cosmology, which presents an entirely new and unexpected model of the universe. What makes this theory so fascinating is that it completely redefines the nature of time. According to this model, time could pass more slowly in regions of the universe dense with matter, while it flows faster in nearly empty areas. This suggests that the universe's age, as we perceive it, may vary depending on location. Timescape cosmology: how much have we misunderstood? In light of recent discoveries, the idea of a singular Big Bang 13.8 billion years ago seems increasingly questionable. Timescape cosmology is reshaping our entire understanding of time and space. The core concept, that time progresses at different rates across the universe, challenges the idea that the cosmos has a single, definite age. It even raises doubts about whether the universe had a single point of origin. Instead, time may flow differently depending on the local matter density. In galaxies and galaxy clusters where matter is abundant, time moves more slowly than in vast cosmic voids where it speeds up. This could mean that billions of additional years have passed in these emptier regions compared to denser areas, making the universe's age relative rather than absolute. It is possible that our entire framework for understanding the universe, based on fixed measurements of time, space, and matter, is fundamentally flawed. We may be on the brink of a paradigm shift, one that not only transforms cosmology, but also reshapes our understanding of human existence itself. If scientists confirm that time is not linear and that reality consists of localized fluctuations, this would not just revolutionize our view of the cosmos, it would force humanity to embrace an entirely new and dynamic perspective on existence. What if similar distortions in time exist right here on Earth? Such an idea could provide explanations for mysterious historical phenomena, perhaps even how civilizations like the ancient Egyptians possessed the knowledge and technology to construct the pyramids. It's possible that they experienced time differently than we do today. But let's return to the universe. Timescape cosmology is far from being a mere speculative idea proposed by a few eccentric scientists. Rather, it represents a sophisticated and logical extension of Albert Einstein's general theory of relativity. Einstein's revolutionary work showed that gravity, along with an observer's position and motion, directly affects the flow of time, demonstrating that time is not an absolute and uniform constant. Timescape cosmology builds upon this foundation, suggesting that not only does gravity influence time, but large-scale cosmic structures and variations in matter density could also play a crucial role in shaping the way time flows across the universe. If this theory holds true, it could redefine our understanding of cosmic evolution, challenging everything from the nature of dark energy to the fundamental principles that govern space and time. In fact, Einstein himself questioned whether time was a real physical property or merely a subjective perception. Timescape cosmology takes this idea even further, suggesting that the large-scale structure of the universe actively shapes what we perceive as time. Beyond offering an explanation for the impossibly ancient galaxies observed by the James Webb Space Telescope, this model also provides a compelling solution to the long-standing mystery of the Hubble tension, the conflicting measurements of the universe's expansion rate. According to conventional cosmology, this rate should be uniform, yet different measurement techniques have yielded contradictory results, hinting at fundamental flaws in our understanding. Traditional Big Bang models assume that, on a large scale, the universe is both homogeneous and isotropic, meaning it should look roughly the same in all directions. However, observations from Hubble and now Webb tell a different story. The universe appears far more complex, with structures that are too large, too irregular, and too unexpected to fit within the standard model. The stunning images from JWST have provided the most compelling evidence yet. The universe cannot be just 13.8 billion years old. Dark energy. A fundamental mistake in science? Does dark energy truly exist, or is it merely an illusion born from our limited understanding of the cosmos? For decades, scientists have debated its existence, yet despite countless studies and observations, no direct evidence has ever been found to confirm its reality. This mysterious force was originally proposed to explain why the universe's expansion appears to be accelerating. But what if this assumption is entirely wrong? One of the most revolutionary aspects of timescape cosmology is its radical rethinking of dark energy's role, or rather, its complete absence. Instead of envisioning an invisible force propelling galaxies apart, timescape cosmology suggests that what we observe as cosmic acceleration may actually stem from large-scale temporal distortions. These distortions, dictated by the structure of the universe itself, could explain why different regions of space appear to experience time at varying rates. If this theory holds, the implications are staggering. The universe may not be governed by a mysterious, uniform energy field, but rather shaped by the intricate, dynamic interplay between space, time, and matter density. This perspective doesn't just challenge traditional models of cosmic expansion, it forces us to reconsider the very nature of gravity. For centuries, gravity has been understood as the fundamental force governing the attraction between objects with mass, a concept solidified by Newton and later refined by Einstein's general theory of relativity. But what if this too is incomplete? If our understanding of gravity itself is flawed, we may be on the verge of a complete scientific reset, akin to the paradigm shifts that have reshaped human knowledge throughout history. Consider the shock when early civilizations discovered that the Earth was not a flat plane but a sphere. That realization fundamentally changed how we navigated and understood our world. Now we stand at the threshold of a similar transformation, one that may redefine not only our understanding of the cosmos, but also the very fabric of reality itself. New discoveries don't just change scientific models, they transform everyday perspectives. Consider how people once feared that ships sailing too far would fall off the edge of the world. The realization that Earth is round completely altered human navigation, trade, and exploration. Now, apply that same shift in thinking to time itself. What if time isn't a fixed measure? What if our universe and even our own planet experience multiple dimensions of time? Simply grasping this possibility could revolutionize our entire perception of reality. We might suddenly become aware of phenomena that were once invisible to us, uncovering cosmic connections that have remained hidden due to our misconceptions about the universe. What if the limitations of our current understanding have kept us from seeing the true nature of reality? If time does not flow uniformly, and if space is not as static as we assume, then the fundamental principles that shape our cosmos could be far more complex than we ever imagined. Imagine a universe where time is not a singular, universally synchronized dimension, but instead exists in dynamic, location-dependent spheres, each flowing differently depending on its surroundings. In this view, what we perceive as the age of the universe might not be a fixed number but a variable experience, shifting and evolving across vast cosmic scales. This would mean that regions of space separated by billions of light years could exist in entirely different temporal states, challenging our deepest assumptions about cosmic history, causality, and the arrow of time itself. With this fresh perspective, timescape cosmology acts as a bridge to other groundbreaking theories that question the nature of the universe. One such idea is the crack the void theory, which suggests that the vast cosmic voids, immense regions of empty space between galaxy clusters, play a far more crucial role in shaping the structure and behavior of the cosmos than previously believed. Rather than being mere gaps in the cosmic web, these voids could be essential to understanding how time, gravity, and even matter itself behave on the grandest scales. These voids, some of the largest known structures, stand as evidence that the cosmos is neither homogeneous nor isotropic. This alone suggests they could be key to redefining our entire understanding of reality. This new theory is not only scientifically compelling, but also deeply thought-provoking, extending into philosophical and even mysterious realms. Thanks to the discoveries of the James Webb Space Telescope, we may come to realize that time itself is nothing more than an illusion. If time doesn't truly exist, then how do we determine our age? The nature of time remains one of humanity's greatest mysteries. For centuries, it has seemed constant, irreversible, and inescapable. But what if our perception of time is merely a byproduct of our position in the universe? Timescape cosmology is not the only theory that challenges our understanding of time. Science has long known that time is influenced by location and motion. Now, we may need to take this further, considering that time itself is shaped by the structure of matter and the cosmos. If time isn't uniform, then defining a universal age for the universe becomes impossible. This would profoundly impact our understanding of cosmic evolution, galaxy formation, and even the search for extraterrestrial life. Civilizations in distant regions of space could experience time at completely different rates, making communication and interaction incredibly complex. However, if we could synchronize with their time frame, entire hidden worlds could suddenly become accessible, revealing new possibilities for contact. This also raises deep philosophical questions. If time is merely a concept we use for organization, should we continue to rely on it? Without time, how would we structure our daily lives? Theoretically, we could develop an intuitive sense that guides us toward the right moments and actions in alignment with a greater cosmic flow. In practical terms, this could mean arriving at work precisely when it feels naturally appropriate. No schedules, no clocks, just an innate connection to the rhythm of existence. Rather than being bound by rigid timelines, we would navigate life through an intuitive sense of timing, attuned to the flow of the universe itself. If we embrace this perspective, humanity might undergo a profound transformation. Our perception of time, productivity, and even personal fulfillment could shift dramatically, allowing us to function in harmony with the natural cadence of existence rather than artificial constructs. This could lead to a society where stress and urgency give way to a deeper sense of purpose and synchronicity. Biologically, we would also need to reconsider aging. Science attributes aging to genetics, cell division, and the gradual shortening of telomeres, which are believed to determine our lifespan. But what if aging is not an absolute process, but rather a construct tied to our belief in time? If time itself is an illusion, merely a framework we impose on reality, could rejecting this concept free us from its effects? Perhaps our bodies are conditioned to deteriorate not because of an inherent biological limit, but because we expect them to. If our perception of time shapes our experience of aging, then altering that perception might allow us to slow, halt, or even reverse the aging process. Could this mean that immortality is not a matter of science, but of perspective? If we could detach from linear time and exist in a state of timeless awareness, might we transcend aging altogether? While this may sound like science fiction, it forces us to question the fundamental nature of existence and whether our understanding of life itself is far more limited than we ever imagined. And that's it. The universe is far more mysterious than we ever imagined. Time may not flow as we think, dark energy could be an illusion, and cosmic voids might hold the key to reality itself. As we uncover these secrets, one thing is certain: the journey has only just begun. Subscribe to Spaceverse and keep exploring the unknown. The best discoveries are yet to come.